Hello, let's take a small look at a nice equation for compound interest, and it relates to our work on exponential growth. And this is a special formula, a special exponential growth formula, specifically for compound interest. So that is, it would help us, say you put $1,000 in a bank that earns you 5% every year, a small account like that. Remember compound interest, so let's say I put in $1,000 and I earn 5% interest. That means after 1 year, I would have $1,050 because I would earn 5% on that 1,000. But then the next year, the 5% would equal $5,250. So I would then have $1,102.50. So this second year I earned $52 instead of $50. And compound interest, it builds on it. The more money you make, the more money you earn. The more money you have, the more money you earn. That's exponential growth, something that builds at a rate proportional to itself. So the equation for compound interest. Formula will work if you have a savings account, as I said, at a bank, or maybe you're adventurous and you get a CD account, something with a fixed interest rate. This formula helps you determine how much money you will make. So let's dive into it and kind of think about how this formula works. It is an exponential growth formula, so we see that we have our initial amount right here of P. So that's how much money you put into the bank, that P. I deposit 10,000, deposit 2,000. That's an initial amount, just like our exponential growth. And then on the inside, we've got 1 plus r over n. So this time, it's not just 1 plus r like the exponential growth, but that r, the rate of growth, has a little more going on. Because R is the annual interest rate. So in your account, you will get that you earn 5% or 6% per year. But then also, that interest compounds not always just yearly. Sometimes monthly, daily, quarterly, something like that. And we account for that, how often it is compounded, with this R divided by N. Get a better look at it. That R divided by N. So N, important, is the number of times that interest is compounded each year. So if it's compounded monthly, N would equal 12. If it's compounded quarterly, N would equal 4. And then our power, like our exponential growth function, it's raised to the power, usually in years, but can be days, whatever the unit is. Here, specific to our compound interest formula, T is always measured in years. However, notice, it is not just to the t power, but the n times t power. And that lets us account for how often it's compounded. Because if you have the money in for 5 years and it's compounded monthly, how many times will it be compounded? Well, the 5 times 12. So a total of 60 times that growth will happen. So the n times t helps us there. All right, let's use this in a nice problem. Maria's parents invested $14,000 at 6% per year, compounded monthly. How much money will there be in the account after 10 years? Let's lay out our variables. P. What is the present amount? What is the principal initial amount? How much money do you put in? 14,000. What is the rate? 0.06. Remember, we always write our rates in the decimal form. N. How many times is that money compounded per year? Here's the key word. It's compounded monthly. 12 months in a year, so 12. And T. How many years is the money going to be in? 10 years. T is equal to 10. So now we will write out our formula and plug in our values. So A, that current amount, how much after 10 years, is equal to 14,000 times 1 plus our rate divided by 12, number of times compounded, to the 12 times 10 power. At this point, we've done a lot of the heavy lifting, and now just let your fingers go to work on the calculator, and you get 14,000 times 1.005 to the 120th power. Get your fingers working again and plug all that in the calculator and get yourself the number 25,471.55. Round it to 2 decimal points because we're talking about money here, and money has dollars and then cents. So the 2 decimal points for our cents. So after 10 years, that 14,000 will be worth 25,471.55. Good return on investment for Maria's parents. It's not too difficult to work these formulas, especially once you figure out what your variables are equal to. Just plug it in a calculator. So we'll try another, get used to where our variables are. Determine the amount of an investment if $300 is invested at an interest rate of 3.5%, compounded quarterly for 22 years. What is the amount if it's compounded daily? So we're going to do this one twice and just notice how the effect of how often is compounded. What does that do to your money? So first, quarterly. Quarterly, I've got that my principal amount is $300. My rate, 3.5%, so that's 0.035. It is compounded quarterly. That is, we are splitting our year up into 4, so n is equal to 4. And then t is equal to 22, putting in there a long time. All right, lay out our formula. A is equal to 300 times 1 plus r divided by n, so 4, to the n times t power. Now once again, go to your calculator and plug this in. I encourage you to plug this in before I give you the answer, just to practice using the calculator, making sure you get your exponent correctly typed in to the calculator. But after getting in the calculator, we get that the money has grown to $645.76. That is quarterly. Now let's try real quick what happens if instead of quarterly, it's compounded daily. Okay, so A is equal to 300. We're still putting in 300, but this time, instead of n equal to 4, daily, how many days in a year? 365. So that money is going to be compounded 365 times. Again, I encourage you to type this in your calculator and then check your answer with what I get, just to be sure that you're getting the steps of how to type in your calculator correct. After putting that all in the calculator, I get $647.91. This is the daily. Interesting to see how the more often you compound it, it gets you more money, which I think that makes sense. The more often you compound the interest, the more often you get the interest, the more money you'll make. But it doesn't make that much of a difference. You only get $2.15 more by compounding it daily instead of quarterly. So interesting how that more often you compound doesn't make a super big difference. So something to keep in mind as you're maybe consulting different savings accounts and things like that. The big thing to look out for to get the best deal is going to be your interest rate. You want the higher interest rate. That's more important than how often it's compounded. Though, how often it's compounded does affect it. And with the bigger amounts of money, if I had put in not 300, but maybe 3,000, then the difference between quarterly and daily would be even larger. So the more money you put in, the more effect the amount of compoundings is. However, that interest rate is still the most important thing.